All right, everyone. Thank you for joining us this afternoon or this morning, depending on where you are in the country. Um, we'll go ahead. There's some people kind of joining last minute, but I want to be respectful of time, so we'll go ahead and jump right into things. My name is Ben Follett. This is the Discover the Power of RISA 3D webinar. We'll go over a few kind of housekeeping things, and then we'll just kind of jump right into our content for today. So the first kind of housekeeping thing that I wanted to kind of touch on is just the Zoom settings. So if you're having problems with the audio, hopefully if everybody can hear me, if you're having any issues with the audio, please go ahead and drop that in the chat. Just let us know. We've got some staff there that's monitoring that. The other thing is, because it's a Zoom webinar, if you have questions, there's a little Q&A button in the bottom right hand or the bottom corner in the Zoom controls there. So you can go ahead and click Q&A. It should pop up a little box there, and then you should be able to type in and ask questions there. And then our staff, again, will be able to answer the questions in that way. And so we'll do that for the majority of the webinar rather than just trying to have a live Q&A session at the end. So first and foremost, this webinar is really intended for people that are not familiar with RISA 3D, or not familiar with RISA products. We're just really talking about the basics here. Obviously, if you are a RISA 3D customer, or if you have used RISA 3D in the past, you may find some of what we're going to talk about beneficial. You may find some tips and tricks and some other things, but really the goal here is to talk about, the very basics, the very kind of reasons why RISA 3D, for those people that don't use it, is one of the most popular structural engineering tools on the market, right? And so for those that you don't know or maybe aren't as familiar with, RISA is a company, and I always like to say partners with structural engineers to provide them with an integrated suite of industry-leading structural analysis tools for buildings, infrastructure, and manufacturing, so that they can confidently design and deliver projects on time and under budget. We really focus on that idea of partners. We, for the most part, are a company of engineers really trying to serve the engineering market. I myself, lead our sales and marketing efforts, and I am, a professional engineer as well. So across the RISA brand, again, we're going to focus on RISA 3D, but we have a bunch of different software products. These are our main RISA products. We also own the Adapt software products. And again, we're going to focus on RISA 3D today, but in our follow-up after the meeting, if you have questions on any one of these things, we're happy to get together some time, do a virtual meeting, have you meet with one of our engineers, or reach out to support to answer any questions that you may have. In general, though, just kind of a little hierarchy, again, with the goal here of talking about RISA from hey, maybe you don't know who we are, maybe you're not as familiar with us. I like to say that RISA has kind of 6 main pillars. The first being the idea of simplified model creation, right? Really just trying to allow you to create model information as simply as possible, whether it's complex or not, being able to have the tools at your disposal to create models simply. Obviously, also a fully integrated workflow, whether that's integration with Revit or it's integration with the rest of our products, be it RISA 3D with RISA Floor, or RISA 3D with RISA Foundation. We really want to have this fully integrated, cohesive workflow available to our customers. Also, we feel that comprehensive reporting is just the basic thing that we have to do. And we're really working towards that with all of our products, but RISA 3D especially gives you as much reporting, whether it's graphically, numerically, or in detailed reports as possible. Again, next, because we say that we're for engineers by engineers, we want to create software, we want to support software, we want to be there to provide support and documentation and resources for you that we feel are really going to be helpful to deliver what we need to. And finally, we offer a flexible cloud-based licensing solution. And so all of our licensing is based in the cloud, where we become your license administrator. The products are still downloaded and installed locally, but that flexible solution allows you to scale up and scale down as you need it, but also provides you kind of a fixed annual cost for your licensing. Now today, like the webinar kind of led from the start, was we're going to really focus on these, what we call these top 5 reasons that engineers are choosing RISA 3D. And so we'll go through these reasons with some different models and talk about those with different ways. But so the 5 reasons: intuitive and efficient based modeling. We say reason number 2 is a partner for every project. 3 is reporting and validation. 4, a seamless integration. And then 5, very obviously, but top-notch training and support resources. And so with that, I'm going to go ahead and jump directly into RISA 3D, the software, and we can go ahead and get started here. So hopefully, again, you should see RISA 3D now. Again, for those who are familiar with RISA 3D, this obviously looks very familiar. For those not, really a basic ribbon interface. Um, maybe something that you're used to, whether you're using Revit or you're using even Microsoft Office tools. I think a lot of the popular software now are kind of going to these ribbon-based interfaces. And so using those tools, RISA feels very analogous to that. Now, all of our tools, RISA Foundation included, and RISA Floor is obviously one of our other main tools, is actually moving this way to see an interface like this. And so that should be something that we see a little bit later this year, really with the goal of providing one type of interface that has shared tools across our products so that if you know one thing, in most cases, people know RISA 3D from the start, that you really feel comfortable using the other products. So that when you switch, when you jump, you don't have as much of a learning curve. Hey, I want to add RISA Floor, I want to add RISA Foundation. I know RISA 3D. You're going to know a lot of those other products just out of the gate. And so just the very basics, right? We've got our modeling interface here. We've got our properties similar to what you would find in like a Revit or an AutoCAD like, and then the Explorer. RISA is a spreadsheet-based package. And so anything that you do graphically, anything that you want to modify or manipulate in the interface, you can also modify and manipulate in a graphical way as well. Now, we're going to talk about a few different things, graphical modeling. We're going to talk about DXF import. We're going to talk about how to use modeling templates and some tips and tricks and stuff like, but let's just go ahead and kind of jump in to some different ways that we can create maybe a similar type of thing in Revit, or excuse me, in RISA here. So the first thing I'm going to do, I'm just going to jump into the settings. And again, we can look at setting up the settings that we want for this particular model. So if I just look at the codes here, I'm going to go ahead and look at the wood codes available to me. These are all the wood codes that we have built into the software. I'm going to use the most recent one that we have here and just click apply. The next thing I want to do maybe is open up a spreadsheet. So I'm going to open up the materials spreadsheet. Again, looking at the wood material spreadsheet. And so again, this is our base set of wood materials that is just kind of installed in the product. But again, any of these spreadsheets, any of these material databases can be expanded by you. So if you just wanted to add a line here and then fill in the information here for this particular type of material, you can do that and you can grow the database. That's pretty simple. So before we start modeling, there's a couple different ways that we can create the members itself. We could just start modeling by clicking members and I can start creating, or what I like to start doing is I like to group elements together in what's called section sets. So I'm going to go ahead over here to section sets and click wood. And I'm going to make two different, we're going to model in a kind of a simple truss. So I'm going to create a top chord here, and I can go ahead and hit this little ellipsis button to kind of build out the shapes that I want. So I'm going to say this is a 2x4, it's a 2-ply 2x4, and it's just going to be solid sawn lumber, so that's fine. I can say, yeah, it's a beam, that's the type, that's fine. The design list, it's going to optimize from the shapes of rectangular double. I can choose the material, so we'll just keep this to the Doug fir. And then I could set up a design rule if I wanted to, basically the characteristics in which these elements are going to get designed by. So if I wanted a depth restriction or a width restriction or a unity check or something like that restriction, I could do that. I'm just going to go ahead and hit enter, and I'm going to go ahead and add in my bottom chord now. Same thing here, but maybe I want to just change the shape, so I'll do that. So we'll use two 2x6s rather than two 2x4s. I'll add another member. We'll call this the web member. And again, I could go ahead and just type in the spreadsheet here, so a 2x6. And we want to make sure this changes to just a rectangular shape because we're just using one shape now. And I'll make this a brace element. And then finally, I'll call this maybe a vert, so like a vertical shape here. And again, we can make that a 2x6 column as well. So now I have all the shapes defined. I can go ahead and start modeling with these group shapes rather than just modeling with an individual shape that's going to get designed all by itself. So if I go ahead and click members here, I'll change my material type to wood, and I can go pick from my section set. Now I can start to draw. You can see I get snaps at my grid lines. I can also go ahead and manipulate my grid lines. And you can see that once I click to start to draw, my drawing tools changed, or my ribbon interface changed to showcase my drawing tools. And so in this case, I'm going to go ahead and I know the size of my truss that I'm going to draw. I'm going to go ahead and change my drawing grid. So I'm going to say, in this case, I want 6 at 5 feet. And then I want just oops, not 19, 10. So this is where I know that my panel points for my truss is going to be. So I can go ahead and really quickly then put in my wood member as my top chord. I could draw in my bottom chord here. I can switch my section set to my verticals, right? And I could draw in my verticals. I could also copy this. So if I wanted to select one of these and say I want to do a global copy, I want to say I want to do in the X direction here by my global coordinate system. So I want 1, 2, 3, 4, 5, 6 of these. So I want 6 at 5 feet, right? That's what we set before. And then I can click apply to selected to get those, right? And then I could also jump back here and continue to model. Maybe I'll do my web members here and just start to add in some of my different web members here. So I can really quickly and easily create this trust element. Now I could select these elements and choose how I want to release them, right? So if I choose all of these elements, again, I just did a highlight here to select all of those things. I could choose that my I and J releases are going to be pinned. And again, if we turn off our rendering, we can go ahead and see that a little bit better. So you can see the little pins there at the end. And so we could start to set this up very simply and easily. And then finally, again, if I wanted to go ahead and just select a few nodes, I could go ahead and then add in my boundary conditions on these things, right? So apply those to selected. I've got 2 boundary conditions. So essentially now I have everything except for my loads and the other characteristics that I could use to create this particular truss. Now, that was just modeling from scratch, right? Now, what if I wanted to go ahead and make some changes, or maybe what another way to model? So again, another way to model in this case is I could use some pre-built templates or what we call our model generation tools. So I'm going to go ahead into our home and click on templates here. And here's all the different templates that are available to us. And so I'm going to go ahead and click our truss option. And so when I select our truss option, we can start to walk through these different, kind of screens to simply and easily define our truss. So I'm going to go ahead and set my origin. So let's set our origin here at like, let's see, let's make it 40 feet out here. So it's kind of beyond this initial truss. And then I can go ahead and set my plane. Okay, the XY plane is what I want. I can set my dimensions here. So let's just say the A dimension is going to be, 8 feet. And the B dimension, the total dimension there, let's see, I want that total dimension to be, actually, let's make this, we'll make it a different type of truss. We'll make this 10 feet. The C dimension, we don't, let's make that 3 feet as well. And then we'll keep the H1 and the H2 on their own. If I hit next, then we could get our panel points locations here. So I could say, hey, I want 4 panels. I want them to be at 3 feet spacing on the left side and the same thing, 3 foot spacing on the right side. That's fine. Next, I could go ahead and set my truss characteristics. So how do I want to dimension this? Do I want it to be centerline to centerline? Do I want it to be out to out? What is pinned? What is not, right? So I could select these. So maybe just my webs are going to be pinned here. Do I want to make any copies in the out of plane direction here? We could do that as well. In this case, I'm going to leave everything the same. Click next. We could also set up our members here. So we define those members already. And if I jump back here, first thing I didn't select, because I noticed it already here, is I didn't select my material and make it wood, which then gives me the section sets available here, right? Because I don't have any section sets for steel already. So I have those set for wood though. So I can say my wood, here's my verts, here's my diagonals. I could rotate them if I need to. I could change them if I need to. So I'll just hit next here again. And then finally, I could set some unbraced length characteristics. So different in and out of plane unbraced length characteristics, top and bottom for compression. In this case, we'll just leave this the same and go ahead and click OK. So here we've got, again, simple truss. So again, like we were looking at, if I wanted to take either of these trusses and I wanted to, global copy them in and out of the plane, I could say, hey, I want 6 copies not in the X direction, but I want them in the Z direction, maybe at -5 feet, right? And I can go ahead and copy those. So I can really quickly and easily start to build out our, maybe in this case, a simple structure, a simple truss, roof system or whatnot. Okay, so next thing we want to do here is I want to look at one other way that we can create kind of geometry, and that's by importing from somewhere else. I know very often you are working with drafters or you're working with an architect. You may have information that you want to bring in for something else. So I'm going to go ahead and just create a new model here real quick. So we don't want to save this. and I'm going to choose to import a DXF file. And so I'm going to bring in this hipped roof. So when I choose to bring in a hipped roof, this was drawn in AutoCAD. So maybe an architect drew this and sent it over. And so I trust the geometry. And so I want to bring that in. So if I go ahead and click OK, I can select the DXF units. So what units was that drawn in? What is my scale factor? What's my vertical axis? And then I can go ahead and click OK. So when I do that, I'm automatically presented with geometry based on what I have brought in. And so in this case, I can kind of get you thin line geometry. I'm getting all that geometry that, I certainly could have drawn in RISA, but is maybe a little bit easier to draw in something like AutoCAD or even Revit because of the complexity of those CAD modeling tools, right? There's maybe a few more routines and tools to do that type of thing, or maybe you're having someone else draft and you're the one doing the engineering. And so in this case, when I imported a DXF file, I automatically natively got node coordinates. I got the connectivity I wanted. Obviously, I could select the members, right? In this case, it's just a generic member, but I could easily do some selections to do some different things. So if I look at maybe changing the view here, so I'm going to use an XZ view so I can get kind of a top-down view of everything. Maybe I want to select this kind of interior portion of the roof here, right? And maybe I wanted to apply a load to all these elements, right, at the same time. So I could go back to my home case here and say, okay, do I have any loads? So the first thing I need to do is to create a basic load case. So I'll just create a simple basic load case that includes my gravity load on here. And with that now created, I can go ahead and add in maybe some line loads. So I'll go ahead and just add a simple line load in my dead case and say my magnitude is going to be 50 pounds a linear foot, right? And I can go ahead and apply to those selected members, right? So now I've got those members applied. I've got that applied in the way that I want, right? Now, if I want to apply load to the other side, again, I could do a selection, or maybe I could use some of my selection tools here. So one that I always like to use is this invert select. So I'm going to click this tool and it's going to invert the selection, right? And I could go ahead then and say, okay, well, I don't want 50 pounds a linear foot in this case. I want 150 pounds a linear foot. Apply to selected, right? So now I have the inverse created and added in that selection there. Now, one of the things, like we all know as structural engineers, that we encounter is that what happens when we need to make a change, right? So it's easy to add the first time, but when you have to make changes, there's a lot of software that changes are difficult, right? And so in this case, maybe I want to make a change to all of these loads, or maybe, I had these loads, and maybe let's call these, maybe these were downward pressures for wind load. And maybe that load, we were under an exposure category, was like an exposure category B or something. Now it changes to a C, our wind pressures change, but they all change by generally the same factor. And so very easily, I could go ahead and say, let me go open my distributed loads spreadsheet, right? And instead of trying to grab these loads and change them manually, I could just say, okay, I'm going to grab all the N magnitudes, both columns. I'm going to go ahead and right click, and I'm going to say, I want to math on selected cells. And instead of adding, I'm just going to multiply and say, I'm going to increase all of these by a factor of 1.5. And so now really quickly and easily, I could go ahead and increase or decrease or add or divide or whatever the loads on that on the model across the board just by doing some math in the cells in kind of the Excel spreadsheet sort of deal there. So very easily, again, we can make those changes without having to say, hey, I'm going to select one and make a change. There's also ways to do that graphically, but in this case, when you have a large amount of elements, it's probably best to do it in a spreadsheet operation. Okay, so let's go ahead and switch models now and talk about our second reason for why people choose RISA 3D. And I'm going to go ahead and choose this RISA 3D multi-material model. So I don't need to save this. I'm just going to open up another model. And so really the idea behind this model is just to really show off that RISA can be a partner, and we'll show a couple different models, but a partner for any project type. So this is kind of a unique model in the sense that it's maybe not overly realistic, but it has almost all materials and element types that exist in RISA inside this one model, right? I've got concrete plates, I've got concrete walls, I've got some masonry walls, I've got some wood framing, some cold form framing, some concrete framing, some steel framing, some aluminum framing. All these things are incorporated and included here in RISA 3D. Now, when I look at, for instance, if I look at the walls, right, I could go ahead and double click on a wall here and I could get into the wall editor and really kind of hone in on exactly what I'm looking at. Again, it's created regions for me based on where the openings are. I could set the wall design rules here. So in this case, the wall design rules define how the wall is set for the rebar that's going to be designed. And again, this is for any type of wall panel, whether that's a masonry wall panel, a wood wall panel, a cold form steel wall panel, or in this case, a concrete wall panel. Now, if I wanted to, I could go ahead and, make changes and adjust things in my model on the fly. So maybe in this case, I don't want, I want to change materials or something like that, or I want to change members, right? So I can just kind of make a quick selection here, and change. I don't want these to be double angle roof bracing, right? I don't have another section set. So maybe I could just change them to an independent shape, and I can, change my angle type, or I can make these maybe a WT or something like that, right? So I can just go ahead down here and pick, a simple, that's probably too big. Pick a simple WT here to use as that shape, right? And then make sure that I'm changing and adding to this in that case. When you have a model that has a few different types of things in it, I think the most unique or the most kind of useful types of tools are selection types of tools. And so if I wanted to say only select, the steel on a certain level, right? So I could say, okay, give me a side view. I want to select the steel here and I want to make changes, but I want to, a lot of times when you have a lot of geometry in the model, right? Making a change and not grabbing the right thing, can be challenging. So maybe I'll, in this case, turn off, the visibility of certain things. So I can still see the background visibility, but everything else is locked out. So I can't make changes to these things, but I can make changes to what I have selected here, right? So that's one of the options there, right? I could turn them off completely, right? So if we go ahead again, select the elements that we want to select here, I could go ahead and use our, viewer mode, or I could use our lock to turn those elements off completely to see what's available there. I could also use other selection tools like opening up save selections. So if I have a save selection here, I can create those selections so I can go back to them time and time again. So if I wanted to say, hey, show me just the tower, right? There's my tower selection, right? Or actually show me just my column strip, right? This little strip here in the middle that has the column there. Now I can get the background geometry as well, but I could go ahead and look at these different save selections that I have available to me so that I can kind of really toggle through the model very quickly and easily. Again, I could use the inverse selection, or I could always use just generic selection tools. So let's get everything back here. Let's do save selection and let's close this out. So let's bring everything back. There we go. Okay. So we could go ahead and also look at selection, one of my favorites, selection by property. And so selection by property really allows you to select based on almost any property that you can think of. And so in this case, if I wanted to say, hey, show me everything by a certain node label or a certain member type, maybe I want to say, show me everything that's hot rolled steel. Select. Okay, that's everything that's hot rolled steel. Show me everything that is hot rolled steel of a certain material, or maybe it's this concrete material, right? So now I'm adding things to my selection. Obviously, I can clear this selection and do different things, but I can build selection criteria and then, just like we saw, save that selection criteria in a variety of different ways. Now, one of the things that's also pretty common that I see is that, hey, RISA is being used not only for larger building structures, but for pieces and parts of a structure, or like in addition to a structure, or, whereas RISA floor is maybe more tuned to do a full multi-story building, RISA 3D, or the model that comes from RISA floor into RISA 3D, is being used to add a canopy or a mechanical unit or something else. And so in this case, we can use something like, I have a colleague of mine who worked in like the telecom industry, and they had a lot of the same kind of telecom mounts that were used all the time, right? And so they had a library of those telecom mounts. And again, it doesn't have to be a telecom mount. It can really be anything that you do, regularly, but they had a library of those telecom mounts that they used all the time. And so they would get a model, or they'd have to build a larger model. And then instead of remodeling that each and every time, they could do what's called append. And so in this case, I'm going to go ahead into File, and I'm going to choose to append my model, append a different model into my existing model. So in this case, I'm going to choose this RISA antenna mount, and I'm going to go ahead and click Open. Do I want to save changes? No, I don't have to save changes. That's okay. So now I have this antenna mount here. Now, this is where this antenna mount comes in, and based on where it was drawn in that original model, but I actually know in this particular situation, I need this antenna mount over here connected to this concrete wall, right? So I need it over here on this green wall over here. And so I've got to move it. And so let's go ahead and I'm going to turn on a little bit of the node geometry here. And I can see, all right, I've got a node here. This is this N30. And so I'm going to go ahead and select that node and I'm going to move it. I'm going to move that element by using a point-to-point move here. So I'm going to go ahead and grab that node. I'm going to apply to selected, and then I'm going to select that node here. And I'm just going to move it down to the very top of the wall over here on this concrete wall here. So let's put it right there. Now, I also know that I still need to, with this selected, I still have this selected on purpose because now I can rotate this, right? So again, I'm still with this selected. Under my modification here, I could then, instead of just do a point-to-point move, I'm going to do a rotate move here, rotate it around which axis. So I got to choose, this is the vertical Y axis that I'm kind of rotating around here. So I'm going to choose Y here, set my rotation angle at 90 degrees here, and I'm going to go ahead and apply to selected again. And then I'm going to pick my origin point and go ahead. So now I've got this rotation here. So again, now I'm kind of in the place where, hey, this is exactly where I wanted this to be. And so if I turn my rendering back on, right, I've now got this kind of steel structure. And if I wanted to shift it down the concrete wall here because I had to, I could. But essentially now I've got this steel structure that is attached or will be attached to the wall because this wall will mesh. And then I can add loads to this antenna mount, and then I can go ahead and I can go ahead and apply loads and then get the analysis as this antenna mount is impacting that concrete wall. And so again, this is really any type of component template that maybe you can think of. Again, I think that very often we don't think about how we model and analyze these smaller pieces in their own models, which is totally fine, but we also want to see the impact on the larger structure. And often enough, what we end up doing is we take the reactions or take the output from that smaller model and add those reactions to, our larger model, or maybe even in the case of RISA 3D or superstructures and foundations, we take our superstructure loads as reactions and we put them onto a foundation model in another software. Again, trying to use what's available to us, the workflows and the tools that are available to us to make sure that we don't miss anything, right? So now I can take that, and instead of having to analyze them separately, analyzing them together and seeing the real world impact of the totality of the model. Okay, before we move on to talking about reporting and validation, I want to open one other model here. And so let's go ahead and open up, let's go open here. And I'm going to go ahead and choose this model that I've just kind of called multi-scale. So I'll hit no here. Basically, I've just created a model that has a variety of different model types in it, right? Basically, from big to small, right? And so whether you're here and you're doing big buildings, or you're saying, hey, Ben, I don't do anything that big, I just do frames, right? RISA is good. RISA is your partner. RISA 3D in this case is your partner for all those different types of things, right? If you need to do an antenna mount like we did, if you need to do a wood truss like we started in, whether that's modeling from scratch or you're just doing roof structures or something like that, right? And you're doing mounts on roof structures, and you need to bring in the roof structure from a AutoCAD file, right? We showed that import. You could do something like that. You're doing a little support tower. Maybe this is maybe this is a tower. Maybe this would be like a water tower or something like that, right? We've got a more of a multi-material thing, using, our structure there, right? Maybe I've got a little kind of, a support system for like a pipe rack or something like that, in that case. And then I have, something much larger like a multi-story building. Just because we're looking at this multi-story building and I see this question that just popped up in the Q&A, someone asked, hey, can you do a building in RISA 3D, or do you need another program like RISA Floor? So that's a great question. So you can do some building elements in RISA 3D. So obviously this has been modeled in RISA 3D. This model didn't come from RISA Floor. It was created itself in RISA 3D, but RISA Floor does have some functionality that RISA 3D does not, right? RISA Floor is based on, similar to like you would find in like a Revit, that it knows that it needs floors, right? So there's certain things that you can do in a floor: automatic infill framing, diaphragm, setting up diaphragms, doing composite beam design, doing wood joist design or steel joist design. All of those things require a floor system generally, right? Or a diaphragm in that case. That's something that doesn't necessarily exist by default in 3D, and RISA 3D is a more of a general finite element analysis or general modeling and analysis tool. And so really what I say is if you're doing multi-story buildings, 2, 3, 4 stories, the most efficient workflow with all the tools and bells and whistles that you want is one where you use RISA Floor and RISA 3D together. RISA Floor then becomes your place to model gravity elements or model the entirety of the structure and design gravity elements, whereas RISA 3D then becomes your lateral system. You can apply 3D, or excuse me, rigid, semi-rigid, and flexible diaphragms when you're coming from a RISA Floor model. But RISA 3D by default allows you to do some very basic rigid diaphragms just defined based on the height. Basically, you define a node at which that you want the diaphragm to be, and then every node at that level would be rigidly locked together. So you have more flexibility with diaphragms when you go with RISA Floor, but you do have some ability to do rigid diaphragms only, flat rigid diaphragms only when you're working in RISA 3D. So again, the idea here is that whether your project scale is something like this 2-story, 3-story structure, or something as small as the truss that we looked at, or this little antenna mount, you have a partner for any type of project with RISA 3D. You can really do, kind of the sky's the limit. I love calling RISA 3D the Swiss Army knife, right? Because it has so many different tools and so many different ways that you can manipulate and create geometry, based on, the different model structures, the different types of things that we as structural engineers do all the time. So let's jump into reason number 3. And it's one of my favorite reasons because I think it's an often not overlooked thing when we're talking about software, but I think it has huge levels of importance when we're talking about how we model and how we create information. So I'm going to go ahead and open this integration model in RISA 3D. So again, here's just another kind of simple multi-story structure. This one actually did have geometry that came over from RISA Floor, but now we're kind of looking at it in RISA 3D. And so in this case, though, I want to look at this model to talk about reporting, right? Every software has a different level of reporting capabilities, right? But as structural engineers, reporting is so paramount to what we do because we're always validating our results either from ourselves, we're validating them for someone else, or we're having to turn those into a code official or to a plan checker or to have drawings in a certain phase that allow that to happen. And so if we go ahead and look at this particular model, we can go ahead and look at some of the different results that exist. So before I go ahead and run a model here, I'm just going to go ahead and look at a beam. We've got a beam selection here. Again, I have all of my properties that are available to me, and these properties are obviously set up. Some of these different properties for unbraced flanks and stuff like that are part of how that analysis is ultimately going to be run, and the design code check is going to be run. I just saw this question too, so I thought I would mention it. Again, in our member releases, in this case, I'm just doing pin because this particular member is not part of a moment frame system, but I can do partial fixity releases, right? So I can do a partial fully fixed release. When we're doing a partial fixity, we are putting in a spring, like a constant there, so a kip foot per radian. So we're not just saying, hey, it's 50% or 40% released or something like that. You'd have to calculate that release, but you can put in that partial fixity release both in the MY and the MZ direction, right? You can also use different things like Simpson yield links or some other different custom releases if you want to. Now let's go ahead and before I run results, let's look at the load combinations I have available for me. So I've created a bunch of different load combinations in this case. And so we've used the load combination generator. So I could generate load combinations based on what I need. So gravity, wind, and seismic based on the load combination code that I'm using. One of the things I always like to mention here is that, again, because everything is a spreadsheet, we have the ability to create your own custom load combinations in the spreadsheet, and then they just become, part of the kind of the build of the software here, right? So if I wanted to build my own or manipulate my IBC strength spreadsheet, or maybe the one I always think about is like TIA combinations. If I wanted to build my own, I just open up the spreadsheet, I manipulate the spreadsheet, and now I can use that as the generated code combination set for my model, right? So I don't have to just use exactly the generated codes that exist in RISA 3D here. The other thing that's unique about load combinations, I just want to mention really quickly, is because RISA is so flexible in the materials it provides, very often, right, we're having ASD combinations, or we're needing ASD combinations for masonry walls and ASD for wood and LRFD for steel and maybe LRFD for concrete, right? And so as a result, we can go ahead and manipulate and we can select from a design perspective which combinations are being used. So every combination is going to be run from an analysis perspective, and we're going to get results for those things. But you can say, hey, I only want these combinations that I'm running to manipulate or basically go to the design of wood or steel or masonry or whatever, right? So you're not going to get any kind of weird combination crossovers, or you're not going to get any of that stuff if you need it. Okay, so the next thing I'm going to go ahead and do is just solve this. I'm going to solve a batch in an envelope. So basically, I'm going to solve all the combinations. So we get individual combination results, and then we also get an enveloped result. So solve just happened. We ran all our combinations. I don't have a super powerful computer, but we can select the multi-core processing that's going on here. And so the first thing you can see here is that I have results now available on the right-hand side of here in the Explorer. So we had our data entry. Now we have our results. I can toggle back and forth between the enveloped results or the batch results. So for instance, if I start here with node reactions, I can see the enveloped node reaction spreadsheet, right? And so I could say, okay, vertically Y, I want to see where's my max reaction here. So my max reaction here is 198 kips. In the Y direction, I can go ahead and say, show selected lines in current view. Whoops, I should click off of that other beam first. I could say show selected lines in current view, right? And then it's going to go ahead and if I want to, it's going to give me that selection there, right? So I can go ahead and find, kind of quickly and easily find that, right? Selection. And so if I wanted to, I could also say, hey, maybe I want to do a quick find. So I'm going to go ahead and put that label in and auto zoom into that piece. So that's that node right there where we're going to see that reaction. So if I really wanted to kind of check that, I could go ahead and visually turn on my Y reaction here for my envelope load combination. And there it is, right? That's that 198 kips there. And so, we can see this graphically here. We could, again, also see this in a spreadsheet if we want to, and we can look at all of our different results in a spreadsheet. So I'm going to go ahead and it's sometimes, it might be difficult to look at all the results at the same time. So I'm just going to go ahead and pick like one level here. And again, use some of our tools here so that I could just see what we want to look at. So let's go ahead and turn off the rendering here. There we go. Okay, so we've got our rendering off. So now we can look at, if I wanted to go ahead and look at our, moment diagrams on these here, right? So I've got our kind of our simple moment diagrams. Again, I'm looking at it in either a single load combination, right? Or I'm looking at it in an envelope state. I could also go ahead and turn on my unity checks. So if I look at my unity checks here, let's go ahead and see, there's my unity check, right? So I've got my unity check there for these different members. So we can see, pass fail, obviously all these in this particular case are passing, and we could go ahead and we'll show some optimization here. I could also show my loads graphically, again, by load case and load combination if I wanted to, or show some deflected shape, right? So again, I'm just seeing in this case, the deflected shape on this particular floor. Now I could also, if I wanted to, again, if I go back to my unity checks here, so I've got my unity checks again for my envelope here. Maybe I wanted to see this in a spreadsheet, right? But, by default, my spreadsheet's going to give me, everything, the kitchen sink. So I'm going to go ahead and, again, select these members here, right? So let's just give a good select here. And then I'm going to use a filter. So I can filter inputs, but I can also filter spreadsheet outputs. So I'm going to go ahead and click this filter results and say filter out unselected items from results. So I click yes. And when I do that now, if I go into my code check spreadsheet, and because I can do some fun stuff with the interface here, I can just dock this side by side here. So now I've got this view, and then this is my code check spreadsheet. So this isn't obviously every member in the model, but it is the 38 members that I selected here and the code checks that I'm looking at for these particular elements here, right? Now, so I can look at this. I could also, if I wanted to, any results spreadsheet can be simply very quickly exported to Excel. So if I wanted to go ahead and just click export to Excel, I could say, hey, just this tab, because I'm only concerned with hot rolled steel. And I can go ahead, I'll just drop this on my desktop really quickly here. And now open up my other screen, but I'll bring it over here. And so now I just have this spreadsheet now in my in Excel. And so if I wanted to do some post-processing, which we all know, really the most powerful engineering software that exists is Excel, right? Something that we use almost probably on every project. So if I needed to post-process for some reason because there was a check maybe that RISA didn't do, or maybe I had a spreadsheet built already that did something unique, I could bring these results out rather than having to take them out by hand or print out something or what have you. Okay, so the other thing I can do here is I'm going to go ahead and close my spreadsheet out here, and I'm going to go ahead and bring back my results here. I'm going to go ahead and take let's take a little vertical look here. There we go. And I'm going to choose like right here, this kind of like run of columns here, or this kind of frame here. And let's go ahead and just look at that frame here. So if I look at this frame here, maybe this is the view, and let's get a good view here. Maybe this is the view that I want, and I want to send this to a report or something like that. So I've got this view. The next thing I can do is I can go ahead and just click my little camera button up here. So I click my camera, and this, I don't care about my printer here, but it's going to go ahead and give me a model view. Now, and this model view is active, so I can go ahead and kind of tweak it. I can move it around. I can say, ooh, I actually don't want this, load combination. I want a different load combination. I actually want my deflected shape instead of my results, right? Okay, I do want that load combination. Okay, I can look at this. I can look at that. I can kind of tweak what I'm looking for here, right? And then I can, select. I can just kind of move through the selection and whatnot here to say, okay, this is ultimately, what I'm looking for. And then I can go ahead and save that version or this kind of visibility in this model here. So I can do that, just kind of click a snapshot to save that snapshot. Now, the other thing I can do is if I want to go ahead and look at some other results, I'm going to go ahead and just resolve here really quickly. I can go ahead and look at the results for in a different fashion for maybe this column. So in this case, maybe I'm going to go ahead and look at my detailed report. So again, I could have launched that from any of my results tabs, but I can also click on this little detail report over here and click on that column. So when I do that, launches my detail report. Again, this is one of my favorite features about RISA because I think that, seeing a unity check in a table is great, but a lot of times that unity check doesn't tell the whole story, right? Especially if it's a unity check you don't quite fully understand, right? Hey, why is this member failing, right? Like what's happening here? I don't quite understand. And so we try to give you really as much information as we can provide to look at the information that's available to you. So like I can look at the different, plots, but more importantly, I'm looking at, in this case, the axial compression check step by step by the AISC code for exactly, what you're trying to do here. And so pretty easy, pretty straightforward, can see all this stuff. And you could go ahead and even if I wanted to, I could add this full report directly to my my detailed report, my full detail report for creation for returning in that report to a code official or something like that. So we can see all these checks, great for back checking, great for totally understanding exactly what's going on. So once we have kind of the model created the way we want to, I can go ahead then and look at my report. So I can create a larger, more robust report, and that report can include just about anything I want, right? So if I wanted to, and here's that detail report that I just created. So I've got that detail report with, the different sections of my detailed report here. I can change how this looks. I can expand all the sections or not. And then I can start to add, different inputs. Okay, maybe I want, my, hot rolled material spreadsheet to be included here, right? And I can, drag it around so it's the lead thing, right? Maybe I want my, hot rolled section sets. And again, I can move it around, maybe I want my images, right? I had that 3D image here. So I want to see that 3D image here at the end. So I've got that image now, right? I put in some additional detailed reports based on members or whatnot. So I can build this spreadsheet or build this report out with results and input in any way I want. I can then also save that as a template. So if you want to save a stock template, hey, for all of our models, this is exactly how we do this. This is the base report that we do, input and output. I could save that as a template so you don't have to do this each and every time, right? And so you can quickly and easily build those templates and leverage those templates in a variety of different ways. And then obviously I can just, I just say, hey, I want to create a new report template, save that report template, and that now becomes a report template standard in my software. Okay, there's so much good stuff in reporting, but we're running out of time and we don't have a lot. There's so much that we can cover. Obviously, we'll talk a little bit more about some of those things at the end here, but I want to now jump into integration, right? We're not going to talk too much about integration with, like Revit and other things. While we do have APIs with Revit and Tekla that provide integration, we're really focused more on integration with our own software. So, the RISA products really allow you to integrate really fully the models between RISA Floor, RISA 3D, RISA Connection, RISA Foundation, so that the interface that you are currently in is really tuned for the thing that you're trying to do. It's not trying to be something that it's not, right? RISA 3D gives you all these great tools to manipulate and, a superstructure model or the lateral portion of a building structure model or the individual portion. It doesn't have a bunch of tools. It doesn't have a bunch of foundation tools kind of getting in the way and doesn't give you a lot of information that you don't need. So in this case, if I want to save some time and energy and design my foundations, in this case, because I have results, I can up here in the director, just jump directly to RISA Foundation. And so sure, I'll save that. That's no problem. So it's going to run in the background, and it's just basically going to transfer that model into RISA Foundation. Now, the first thing that you'll notice when this launches is that this is a RISA 3D model opening in RISA Foundation. RISA 3D, RISA Floor, RISA Foundation all share the same solver in the background. So basically, it's not creating a new model file type. It's not, doing anything special. It's actually just opening the RISA 3D model in RISA Foundation. And it's giving you really the information that matters to you in this particular model. Now, in this case, we didn't have time for me to build a whole RISA Foundation model. So I've already built one, but we can see the starting point for this model is all of the reaction information that came from my RISA Floor model, or excuse me, my RISA 3D model. So this load here is a load that's from, you can see it here, from this R3D at node N14 in RISA 3D. That's the load. That's that 124 kips. But if we looked enough and we found we could find the live load that went with this, that gave us that overall, total envelope load of 198 kips, right? And so now all of these loads are not my reactions, they are my inputs, right? So they're my inputs to look at all of this different information and then create my foundations. And so in this case, a variety of different foundations that we have. So I've got some matte foundations. I've got some, let's turn on some rendering here. I've got some matte foundations with piers on top here. I've got a matte foundation supported by piles here. So in this particular one, only the piles are supporting the soil, and I've got soil depth characteristics here. I've got some piles and pile caps, some grade beams. Again, I've got a matte slab that we're going to design here, so you can see our rebar design strips there. Got some retaining walls. I also have some different soil. So if I look at soil regions here, I've got two different soil regions that I've defined in different parts of the model. Those soil definitions, again, can define my bearing capacity, my subgrade modulus. I could also see and have different depth of unit weight skin friction if I was doing pile design. So again, creating all of this criteria to be able to look at this. I also have, again, if I was designing my spread footings, my wall footings, I can set up the characteristics and then set up the rules in which these are used to be optimized and designed. So once I have my geometry created and the loads from RISA 3D, I can obviously set up load combinations. The foundation load combinations are going to be different than RISA 3Ds, especially if you were doing only ASD combinations for wood design or masonry design or something like that. You're going to need LFD combinations in RISA Foundation. So we have the load combination generator available for us. But again, creating the load combinations that matter specifically for what we're trying to do in RISA Foundation. So here, again, I can turn on what's for service, what do I want to solve, what do I not want to solve, and then I can go ahead and run this solution here. So if I go ahead and just solve the model really quick, again, another multi-core solution. So it's just going to kind of plow through those results really quickly. And again, give me the results I want. And again, one of the things that you've noticed, and I almost forgot because we've been in RISA 3D for the majority of the time, is the interface looks almost the same, right? It's the same layout. It's got the same Explorer. It's got the same properties. It's got the same 3D view. It's got the same ribbon. Now, there's tools in Modify that are exactly the same, copy, move tools and stuff like that. But now these slab tools are different because they're different Modify characteristics and tools for RISA Foundation, right? The modeling tools, again, are located in the same place, but they're different because of RISA Foundation, right? And so now if I go ahead, I can start to look at some results here. Maybe we want to turn on a soil pressure, right? So we can get our contour plots for our soil pressure to see, okay, we're maxing out at about 1.53 KSF in our slab here, right? We could go ahead and look at something else. So if I wanted to look at a detail report for this retaining wall, I could open up this retaining wall and say, okay, for a certain load combination, that's probably not a good one. There we go. It's a good load combination. Here's the load on the top of the wall. Here's the subsoil pressure being pushed on it, right? All this stuff we could define and create or bring in from the model, right? So here's the overbearing burden pressure. Here's our different pressures in KSF. Here's our force diagrams. And then here's, again, all of our checks that are going on here. So maybe I want to look at my footing design here. So we're seeing the bottom bar design, the top bar design, our soil bearing, right? So it's showing all the load combinations that's calculating the soil bearing to show you, hey, what's the max soil bearing and the unity check that's there? What's our sliding? We have a fixed base, so we're not doing any sliding or overturning, and the wall is propped, so we're not doing any overturning in that case. So again, we can look at all of these results, and again, this is a detailed report that we can add into our detail report output the same way that we did for RISA 3D in this case. Now, if we needed to, and we won't do it in this case, but if we needed to make design changes, the director allows us to just jump back up to RISA 3D, right? So in a situation like where we said, hey, we noticed that there was maybe a failure, maybe we had, the pier was failing because of the load applied to it or something like that, right? And so we needed to shift, this is looking good, right? The compression in the longitudinal bars is fine. And so we're in good shape here, but maybe something was failing. So say, oh, well, we need to manipulate some of the load. I need to reduce the load, the dead load, the live load, whatever. I need to reduce the load that's coming onto this pier here. Well, obviously, because this is from RISA 3D, I can't manipulate this in RISA Foundation. Now, I could detach the model, which basically breaks the connection between the two. But in general, I just want to jump back up to RISA 3D, make my necessary changes. Maybe that's changing the layout of the structure. Maybe that's changing the loading. Maybe that's changing the size of the columns so that the stiffness changes, so that load moves around a little differently. That's up to you. You jump back up to RISA 3D, run the analysis, it updates the reactions, and then you jump back down to RISA Foundation. And again, because it's the same model, the same, kind of base background layer of results and everything, you're able to jump back and forth, right? There's no limitation there on that case. So, I know that was a really quick dive into, all things RISA Foundation, and there's probably a bunch of questions. And again, we've got some elements, especially as we jump into our very last kind of section here, which is, okay, you're interested, I've piqued your interest. I've done my job and I've got you interested in all things, RISA, especially if you're not used to it. Where can we go for help, right? RISA has a ton of resources available. And we really pride ourselves on being able to provide the best training, the best support that, that engineers can get for software. And so we do this in a couple different ways. We've got a really robust blog. And so those are all of our technical articles. Obviously, there's some fun stuff in there too, but mostly technical articles. And I always tell people, if you're looking for a specific thing in RISA, go to Google, search RISA, whatever software, RISA 3D, and then, P delta analysis or, concrete wall design or something like that. The first thing is either going to be a video or a technical article or a help file. So we've done a really good job of making sure that's super searchable for you in Google. The next thing is the online help file, total full searchable online help file. Next is our videos. So we have a video library that's fully robust. All these videos are also available on YouTube, but searchable through the website itself as well. So you can kind of bounce through and say, hey, I want to look for 3D. I want to look at walls. And I want to look at, concrete shear wall design. Oh, here it is. Okay, here's a video on concrete shear wall design, in RISA 3D, right? So very simple, very direct, very straightforward. The other thing that I want to mention is the RISA Learning Center. So the RISA Learning Center is, basically our learning platform that allows you to take classes or do step-by-step tutorials, take an on-demand class or a live virtual class. So we have classes available all the time. You can see here next week, we have a RISA 3D Quick Start course. So this Quick Start course is, kind of our hands-on engineer-led, 4-hour PDH qualified course. You got 2 sessions. You get all the videos and stuff like that. And so all of that is available. You've got multiple live courses available. Also on-demand courses. So you can see there's probably 10 or so on-demand courses, or there's just tutorials. So like if I wanted to jump into this RISA 3D tutorial, I could continue here. And again, this is kind of, if you ever done like LinkedIn Learning or something like that, the idea is here it's interactive. So there's GIFs, there's videos, there's step-by-step things, there's model files that exist. There's a tutorial model that you walk through with this. So this same model you're kind of living in, and you're kind of working through, hey, I'm going to apply this. Here's how I apply these loads. Here's how I make these selections here. Here's how I do these things for surface loads. So it's kind of teaching you in this step-by-step tutorial. And so we have this for RISA 3D and RISA Foundation as well, and Adapt Builder actually. And so a variety of different things that you can do and complete. And so all of these tutorials are available. All these tutorials are for free. The trainings obviously come associated with a cost, because there are because there's PDH qualified and stuff like that. But from a tutorial perspective, those are free to use. The other thing that we want to say is that we actually wanted to, for people that are new to our training platform or new to RISA, one of the best ways to get started is by getting trained. And so we're offering a special training discount on any paid training in our training platform, available to you for 40% off. There's a little code right there. We'll email you this code too, so you don't have to feverishly jot it down here or try to take a picture of the screen here. But if you're interested in taking any of those live trainings, we've got 2 live trainings coming up this month, one next week, one 2 weeks from now, or any of those on-demand trainings on 3D, Foundation, Connection, Floor, Builder, whatever, you can go ahead and use this code in checkout in our customer portal for the next week and get 40% off any of those trainings. The last thing I wanted to mention is technical support. So we have at least 3 to 4 PEs on support ready for you to answer and to ask questions each and every day of the week. So you can reach out via email, support@risa.com, by phone, and those hours are 6 a.m. to 5 p.m. Pacific, Monday through Friday. And so, the team is there available to answer any questions that you have. Generally, I always tell people you can call in, but always send an email with the model file, because if you start talking about a model file, then it's hard to, see if they don't have the model in front of them. But we pride ourselves in making sure, and you can ask anybody in the industry, pride ourselves on making sure that we can support our customers as best we can. And really, it comes back to the thing I said really right from the beginning, is that we're engineers. Candace, who's answering questions, is an engineer. I'm, in sales and marketing now, but I'm an engineer. A lot of our staff is engineers, and we know what it's like to be a structural engineer. We know the struggles that you go through. We know the project deadlines that you have. We know the different restraints that you have on you, and we want to be a part of that process. We want to partner with you to make sure that you are successful as possible. And if that means you're using our software and we can help you do that and be successful, great. That's what we want to do. And so we want you to reach out so that we can help you do that. Now, we just talked about a whole bunch of stuff. And so the next question is, what's my next step? What can I do next? So again, we'll send out some of these links, but if you're new to RISA, or if you're new to one of the other products, maybe you saw RISA 3D today, maybe you already own it, but you saw RISA Foundation and the integration, you said, oh shoot, like I'd really love to learn more about that. We do what's called software tours. And so we encourage you to reach out to an engineer. So we've got go.risa.com/reach an engineer, just simple form fill where you could schedule a meeting with one of our technical staff, so that you can, go over your specific questions. There were, 20 or so specific questions that were asked today. And so we want to make sure that those specific questions get answered, not just in the text or not just by me answering them in a little blurb, but by you sitting there with an engineer and walking through maybe something that's specific to you. Because while we showed all those different project types, you may do one of those that's very specific and have really specific questions on that. So let us prove to you that RISA is a solution that can help you by having a virtual meeting with you. The other thing is start a trial. All of our products, if you don't own them, have a free 10-day trial. So you can just visit the portal, so portal.risa.com/register, and you could just register for an account if you don't already have one, and you could create a 10-day trial. And so all you do is just go to trials, you pick the software you want to trial, it just gives you the license right away, and you got a 10-day trial. If you don't use it, we need to extend it for you a little bit, that's fine too. But all that is available to you, without having to talk to anybody or anything like that. So I know that we are right on time, right at 3 o'clock. I see that there's been a ton of questions that's been going on, so that's great. The last question in here is somebody asked if the video is going to be made available. We are recording this, and so we will send out the video for everybody in our follow-up procedure, probably in the next couple days, just once we get it all packaged up and put together, but we'll send out the video. There are and again, if you have questions, we'll make sure that we follow up and we make sure that we can get some meeting schedules and stuff like that. But we thank you so much for joining us today. If you've got general questions, you can reach out to info@risa.com. I'll stick around for a little bit. I see there's some questions in here. I'll answer those, but we thank you for coming today, and I appreciate the time here. So it looks like there's a question from Canada. Yeah, we're direct reseller across the world. So, we do have some resellers in some markets, India specifically, but if you're buying from Canada, you can buy directly from us. So we don't have a direct, reseller in Canada. So pretty easy to just buy direct for us. One of the great things about the RISA customer portal is it's full e-commerce. So if you wanted to go in there and purchase the training, obviously you can purchase a training with a promo code and just pick the training you want, drop in that promo code, put in the 40% off, click checkout with your credit card, and you're set up, and you could take the training. You could take one of the on-demand trainings right away. So really flexible, really easy to do, and you can buy the software that same way too. Buy the software, click to checkout, and you get your licensing and your receipt immediately. So we're trying to get it to you as quickly as we can. So yeah, we'll keep the meeting open for another minute or two, but we thank everybody for joining us, and we'll hope to see you at another webinar or hope to talk to you in a one-on-one meeting sometime over the next few weeks.